Every summer, it feels like the planet's trying to roast us alive. Record heat waves, melting glaciers, wildfires, and the same question always comes up. Is this really humans' fault, or is it just the sun doing its thing? Here's the deal. The Earth's average surface temperature has climbed about 1.2 degrees Celsius since the late 1800s. That might sound tiny, but on a planetary scale, it's massive. It's like giving a fever to an entire planet. Storms get stronger, oceans rise, and ecosystems shift. Now, yes, the sun does influence our climate. It goes through 11-year cycles of stronger and weaker activity. A few centuries ago, there was even a low sunspot phase called the Maunder Minimum, which matched a mini ice age in Europe. So it's fair to ask, could today's warming just be another solar swing? Short answer, no. Satellite data show that solar radiation has actually decreased slightly in recent decades, while global temperatures keep rising. Meanwhile, carbon dioxide levels, the main greenhouse gas, are at their highest point in at least 800,000 years. Here's what's happening. Greenhouse gases act like an invisible blanket around Earth. Without them, our planet would be a frozen rock at about -18 degrees Celsius. But add more CO2, methane, and water vapor, and that blanket gets thicker, trapping more heat. Since the Industrial Revolution, humans have been burning fossil fuels nonstop, releasing billions of tons of CO2 into the atmosphere. The physics are simple. More greenhouse gases mean more trapped heat. That's not politics, that's thermodynamics. Still, it's not all doom. Solar energy, better batteries, smarter farming, and new carbon capture tech are already helping slow things down. The climate system is huge and complex, but human choices are part of it now. So no, the sun's not the main culprit this time. We are. But that also means we have the power to fix it. And that's baby science for you. Every summer feels hotter than the last. The ocean's boiling, wildfires are raging, and half the internet is screaming, "We're doomed." So, are we? Let's get real. Earth's temperature has risen by about 1.2 degrees Celsius since the late 1800s. That may not sound like much, but it's enough to melt glaciers, supercharge storms, and push ecosystems to the brink. And yeah, humans are the main reason. Burning coal, oil, and gas dumps billions of tons of CO2 into the atmosphere every year. Burning coal, oil, and gas dumps billions of tons of CO2 into the atmosphere every year, thickening the planet's heat-trapping blanket. But here's the good news. Physics got us into this mess, and physics can get us out. When we cut emissions, the concentration of greenhouse gases starts to level off. That means warming can slow down, not instantly, but within decades. We've already seen proof. When air travel dropped in 2020, pollution and CO2 briefly dipped, and the air literally got cleaner in weeks. Of course, we can't just stop everything forever. So scientists are developing tech to pull CO2 out of the air, giant fans that suck up carbon and store it underground, artificial trees that breathe like real ones, and algae farms that lock away carbon in the ocean. It's not sci-fi, it's happening right now. Still, none of that replaces the basics: renewable energy, efficient transport, smarter farming, and reforestation. Every ton of CO2 we don't release makes a difference. And while politicians argue, the planet keeps the score. If global warming hits 2 degrees Celsius, things get rough. More droughts, lost crops, flooded coasts. But if we stay closer to 1.5 degrees, we can avoid most of the worst outcomes. That's not fantasy, that's math. The future isn't set in stone, it's written in our emissions. And the sooner we change the story, the better the ending looks. So no, it's not game over. It's game on, and that's baby science for you. Imagine this. A virus sneaks into your body, maybe from a sneeze on the subway or a doorknob at Starbucks. Before your immune system even has time to assemble the troops, one molecule sounds the alarm. Meet interferon, your body's built-in early warning system. When a cell gets infected, it doesn't go down quietly. It sends out a chemical distress signal, interferons, basically shouting, "Hey, neighbors, there's a virus in here. Lock your doors." Nearby cells hear the message and start producing antiviral defenses even before the virus reaches them. The name interferon comes from interfere, because that's exactly what it does. It interferes with the virus's ability to replicate. Think of it as the spam filter of your immune system, catching infected emails before they crash the whole server. But interferons don't just block viruses. They also call in the big guns, immune cells like natural killer cells and macrophages. Those guys show up, wipe out the infected cells, and clean up the mess. Here's the wild part. This entire response happens in hours, long before your body starts making antibodies. Without interferons, even a mild infection could spread like wildfire. Scientists have tried using interferons as medicine to treat hepatitis, multiple sclerosis, and even some cancers. They work, but not without side effects. Think fever, fatigue, and flu-like symptoms. That's your immune system in overdrive. Fun fact, some viruses, like SARS-CoV-2, actually evolved ways to block interferon production. That's part of why COVID could spread so easily before symptoms appeared. Your body is basically running a 24/7 cybersecurity system, constantly scanning for intruders and updating its firewall. You just don't get a notification every time it saves your life. So next time you shake off a cold without realizing it, thank your interferons. They're the unsung heroes of your immune system. And that's baby science for you. When scientists cloned a sheep named Dolly back in 1996, the world freaked out. Headlines screamed about human clones, armies of duplicates, and Frankenstein science. But cloning isn't as sci-fi or as scary as it sounds. Here's what actually happened. Researchers in Scotland took a single cell from an adult sheep's udder and inserted its DNA into an egg cell whose own nucleus had been removed. Then they gave it a little electric jolt, basically saying, "Hey, start dividing." And it worked. The embryo grew, developed, and eventually became Dolly, an exact genetic copy of the original sheep. But cloning isn't magic, it's cellular reprogramming. Scientists trick the mature cell into thinking it's a fresh, brand new one again, like wiping a phone back to factory settings. And it's hard. Out of 277 attempts, only one worked. Since then, we've cloned cats, dogs, cows, and even monkeys. So why not humans? Well, because cloning a person raises massive ethical and biological problems. It's not just copy and paste. Even identical DNA doesn't mean identical minds, memories, or personalities. A human clone wouldn't be a twin. They'd be a separate person with their own life and experiences. Plus, cloning still involves a lot of failures, mutations, and suffering in animal tests. That's why most countries have banned human cloning altogether. But here's the cool part. The same technology that made Dolly possible is now helping save endangered species. Scientists have cloned black-footed ferrets, Arctic wolves, and are even working to bring back the woolly mammoth. Yeah, real-life Jurassic Park, but hopefully with fewer people getting eaten. Cloning isn't about building armies of duplicates. It's about understanding life, restoring species, and maybe one day, curing diseases by regrowing tissues and organs. So no, we're not mass-producing humans anytime soon. But the science behind cloning, it's already changing our future. And that's baby science for you. If you grew up on Star Trek, you've definitely imagined it. You step into a booth, someone yells "Energize," and boom, you're instantly across the galaxy. Sounds impossible, right? Well, not entirely. Scientists have already teleported things, not people, but particles, tiny ones like photons and atoms. And they didn't move through space. They used a mind-bending trick from quantum physics called entanglement. Here's how it works. When two particles become entangled, they're linked in such a way that whatever happens to one instantly affects the other, even if they're light years apart. Einstein called it spooky action at a distance, and he wasn't joking. Now, teleportation in physics doesn't mean the object literally flies through space. Instead, scientists transfer its quantum state, all the information describing that particle, to another one somewhere else. It's like sending the world's most complicated Snapchat, except the message deletes the original when it's sent. In 1997, researchers in Austria achieved the first quantum teleportation between two photons. Since then, scientists have done it over 60 miles of fiber optic cable and even between Earth and satellites orbiting in space. So yeah, teleportation is real, just not the sci-fi kind. But could we ever teleport a person? Not anytime soon. To transfer a single human, you'd have to record the position of every one of your roughly 100 trillion atoms, transmit that data, and then rebuild you perfectly on the other side. Oh, and the process destroys the original in the process. So technically, you wouldn't be moving, you'd be replaced. Kind of takes the fun out of it, huh? Still, quantum teleportation already powers the future of quantum computing and ultra-secure communication. Messages can be sent instantly and unhackably because any attempt to eavesdrop destroys the data itself. So no, you won't be teleporting to work anytime soon. But thanks to quantum weirdness, information already is. And someday, that might change everything. And that's baby science for you.